Okay, so today we will study about the variation in the value of g. In the last video, I have explained you how to calculate the value of g, right? And I have told you that at the surface of Earth, the value of small g is 9.8 meter per second square. Okay. Now in this video we will see what is the variation of g. Now the value of g changes according to three things. Okay, first is due to the shape of Earth. As we have already studied that the surface or the shape of Earth is spherical, but that is not true. It is not exactly spherical. It is quite like an egg-shaped structure. Okay, this is your egg-shaped structure. Means the Earth is quite bulged out at the equator positions. These are the equator positions, right? And it is slightly compressed at the pole positions. This is your pole position. This is your north pole, and this is your south pole. Okay. Now see, it is evident from the figure that the radius at the equator is more than the radius at the poles. Okay, so this is the condition. Now come to here. G is equal to gm upon r square. This I have already told you in last video. Okay, if you have not watched that video, I will put the link in the left hand side of the video. You can watch that. So G equal to gm upon r square. Now when we will calculate the value of g at equator, the equation will become g subscript e, that is equal to gm upon r square. Okay, we will take the radius at the equator position, that is re. Now when we will calculate the value of g at the poles, then what will be the equation? Gp equal to gm upon rp square, radius at the pole, because mass is constant, value of capital G is constant, that is the universal gravitational constant, so that will not change. Okay. So these are your two equations. Now from the equation C, Re or Rp, this radius term is in denominator. Okay. So by general maths, if this value, the value in denominator is increasing, it means this value will decrease. Okay. So we have already written that Re is greater than Rp. It means the value of Ge, okay, Ge will be less than value of Gp. Means the acceleration due to gravity, the value of acceleration due to gravity at equator will be less than the value of acceleration due to gravity at poles. Clear? So this is your relation between the value of acceleration due to gravity at equator and at pole. So in this way the value of g is changing in these two positions. Clear? Now come to the next point. Variation in the value due to height h above the surface of Earth. See, this is your Earth, okay, and we are taking the object at a surface at a height h from the surface of Earth. Okay, this is the surface of Earth and the object now is at here, and this height above the surface of Earth is h and radius is your capital R. Okay, now see, g is equal to gm by r square. This is the normal equation of calculating small g. Okay, this is your equation number 1. Now in this case we have to calculate the value of small g at this position. Okay, so equation will become obviously g small h, g subscript h is equal to gm upon r plus h whole square. Why? Because now the distance between the object and the Earth is r, this radius of Earth, plus this height. So in place of r in this equation we will write r plus h whole square. Clear? Now this is equation number 2. Now what we will do, dividing equation 2 by 1, this by this. So gh by g is equal to gm upon r plus h whole square into this one, this value gm into r square. Okay, so gm will get cancelled. What you will get? Gh by g is equal to r square upon r plus h whole square. Okay, now see, again there is a common simple math that r plus h will be greater than r. Obviously if we are adding some quantity, some height with this r, then it will be greater than normal r. Okay, so if this quantity is greater than r, then this value gh by g will be less than 1. Okay, because this value is less and this value is more. So when we are dividing a less quantity with the higher quantity, then what we will get the value? Small value. Okay, so gh by g will be less than r. Okay, less than 1. Therefore gh is less than value of g. Okay, it means the value of G at any height above the surface of Earth is less than the value of G at the surface of Earth. It means GH is less than 9.8 meter per second square. Why? Because at the surface of Earth we are taking G and that is equal to 9.8. So whenever we are going at some height, then the value of G decreases and we will not get the 9.8 value. It will be less than 9.8. How much that will value, that we have to calculate. Okay. And one more thing, this description is for class 9 specifically. Okay. In 11th there is a complete description and, or I can say, a strict or precise formula, precise way to calculate what will be the value of G at some height. But in your class 9th we cannot use that method because it involves binomial theorem, and in class 9th you are not familiar with that binomial theorem, so you can't use that thing. So right now in class 9th you can only see this thing and you should know that the value of G decreases when you are going above the surface of Earth. Okay. Alright, now come to the last thing. The last effect is due to the depth T below the surface of Earth. Okay. Now see, this is again your Earth. Okay. This is the center, and this from here O to this surface, the radius is capital R. Okay. Now we are going at a depth D from the surface of Earth, means from here to here. This is the point where we are going inside the surface of Earth. So this distance is small d we are taking. Therefore total distance is capital R and this distance is small d. Therefore this will be R minus d. Okay. Now see, we have to calculate the value of G at this point by using this formula. G subscript d is equal to 1 minus d by R into G. Okay. So this G is coming here, and when we are rearranging the thing, we are getting G d is equal to G into R minus d by R. Okay. Now see, if the if the value of d is increasing here, it means the value of GD will decrease. Okay. So the GD value of G at any surface at a depth D will be less than the value of G at the surface of Earth. Okay. So in this way again you are getting that GD, value of G at any depth, is less than 9.8 meter per second square, which is at the surface of Earth. So the conclusion is that the value of small g is 9.8 at the surface of Earth, and if we are going above the surface of Earth, the value of G will decrease, or if we are going below the surface of Earth, then also the value of small g will decrease. Clear? Now one more thing, the calculation of value of G above the surface of Earth or at a depth below the surface of Earth, that you have to do by using binomial theorem. And in class 9th you don't know, you have not studied about the binomial theorem, so you can't use that exact formula. It is in class 11th. Okay. So for class 9th you have to understand the thing that how the value of G changes. You don't have to calculate the exact value. Clear? Now if this video is you found useful, then like the button and subscribe the channel. And if you have any doubt, then you can ask in the comment section below. And yes, there's one more thing. There is one more factor which is due to the rotation of Earth. The value of change in the value of G due to rotation of Earth. So that is in class 11, and I have already made that video. So I will put that video link in the end of this video. So if you are interested, then you can watch that video. Okay. Thank you.